Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about array question number 209. Minimum size subarray sum. Given an array of positive integers nums and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, then return 0 instead. Okay, fine. We want to find what is the minimal length of a subarray such that which sum is greater than or equal to the target. They are given in a question. Okay, fine. Now just see here. First of all, we want to know about what is meant by subarray, right? Okay. So subarray is something like a subset of a given array which is contiguous or continuous and also should be in order. Okay, just see here. 2, 3 is a subarray. 2, 3, 1 is a subarray. 3, 1, 2 is a subarray. 3, 1, 2, 4, 3 is a subarray, and anything that is contiguous is a subarray. If I take 4 to 1, whether it is subarray, 4 to 1 is subarray? No, because it is not in order, right? So it is not a subarray. Okay, if I take 2, 3, 3, whether it is subarray? No, because it is not in a continuous order, right? Because I picked only 2, 3, and 3. So it is not a continuous. Okay, so to be a subarray, it should be a continuous and also an order, and also it should be present in that array. That's why I'm saying that subset of the main array. Okay, so that is a simple explanation for this subarray, and whole array is also a subarray. That's for your understanding. Okay, now also an empty array is also a subarray. Okay, fine. So that's what a subarray. Now I hope you understand 100% what is meant by subarray. Okay, now let us see this example. See here, target is 7, and what are the subarray we can generate such that the target will be 7. Okay, simple. I can generate just 4 and 3, right? 4 and 3 is a subarray. Okay, let me write down 4 and 3. Okay, whether there is any one, yes, 1, 2, and 4. Another possible, right? Okay, whether any other I think so. There may be any other, but I don't know to find them. Okay, fine. There may be any other. Okay, but there is no subarray that is less than the length of 2, right? The only subarray which is a minimal and gives the target is only this 4 and 3, right? So I can say the answer will be what? 2. Okay, understand this. Okay, fine. Now just see here, target is 4, nums is equal to 1, 4, 4. Here I can say this 4, either I can take this 4 as a subarray or this 4 alone as a subarray. Simple. Sum of that subarray will be what? Equal to the target. So I can say it is a minimum possible, only 1. Fine. Okay, now take this, target is equal to 11, nums is equal to this many 1, all are 1. Okay, if I add entire array, whether I can get this 11? No. Just see here, there are totally how many 1? 8, 1, I think so. Okay, 8 is less than 11, right? So by adding the entire array itself, I cannot get the target. And how come I can get a target? Okay, so I just written what? 0, because it is impossible to form this target. Okay, fine. So let us find how to solve this question in a brute force way first. So what is a brute force way? So brute force way is something like I want to generate all possible subarray. Okay, I will give the link in my description to find or generate all possible subarray from a main array. Okay, and this is the first step. And what is the second step? The second step is to find whether that subarray sum is equal to the target. Okay, so if it is so, then I want to take amount of all subarray size, which subarray size is very small, and I want to take that subarray size and return. That's it. Hope you understand this, right? Okay, fine. Now my time complexity and space complexity will be what? Okay, my time complexity will be something like I want to take all possible subarray, right? So it will be n cube. Okay, while taking itself, I can do a sum operation also. So it will be n cube, and I can further optimize it by n square. Okay, first we can see the brute force approach. It is n cube. And what is space complexity? It is O of 1. Okay, and in better approach, I can reduce a for loop, okay, of generating three for deriving a subarray, we want 3 for loop, right? Instead of that, I can take only 2 for loop and I will do a prefix sum operation. Okay, that's a better approach. So I think so you can understand this, and it will be O of n square, right? And space constant v remains O of 1. Okay, now my question is whether I can do this problem in a linear time. Okay, whenever there is a keyword called subarray or substring, what is our first thought? Our first thought is going to be sliding window. Okay, let us see what is the sliding window technique for this problem, to solve this problem. Okay, first of all, I will take L pointer and R pointer pointing to the 0th index. Okay, now I want to take result as infinity, which means what? The maximum number or into max you can take. Okay, now what is the sum? I want to take the sum as 0. Now, what's the target? Target is 7 as in the question itself. Okay, now what is the question stating? It is stating that we want to find a sum of a subarray which is greater than or equal to the target, and also the length of the subarray is minimal in a possible subarrays. Okay, fine. Now, just come here. So, first of all, here what is it? It is 2, right? Okay, I want to update this 2 in my sum. Okay, update this 2. Now, whether this 2 is greater than this target? No. Okay, just update the R pointer. Move ahead. Okay, now whether this 3, okay, now 3 should be added, okay, so it will be 5. Whether this 5 is greater than this target or equal to this target? No. So I want to again expand. Okay, now plus 1 is equal to 6. 6, no. Okay. No. 8. Whether 8 satisfies the condition? Yes, it satisfies the condition. So what should I do? I should take the window size. What is it? Window size formula. Window size formula is R minus L plus 1 is equal to, here we want to take 3 minus 0 plus 1 is equal to 4. Okay, 4 is where better than the infinity. So update this as 4. Fine. Now just understand, if I keep on expanding after this point, our target values always be less than the current sum. That's 100% sure, right? But we don't want a maximum length. We want a minimum length, right? So I want to shrink it. I want to shrink it such that maybe while shrinking, I can get a lesser length of a subarray with a greater or equal to the target sum. Okay, so I want to shrink now. Okay, by shrinking, I want to take this L and make here such that I want to exclude the 2. That's it. So while excluding this 2, we want to exclude the sum also, right? So minus 2 is equal to 6. Oh, the 6 is what? Not greater than the target or equal to the target. Okay, just expand. Okay, now 4. So plus 4 is equal to 10. The 10 is greater than or equal to the target. So what is the length? Length is 4. So don't want to update this 4 because already the best case is what? 4. Result is already what? 4 only, right? So we don't want to update it. And we want to shrink it, right? So shrink. L becomes here 3 is excluded. So 10 minus 3 is equal to 7. 7 is again greater than or equal to 7. So now what is the sliding door size? It is 3. Can I understand this? Why I am just shrinking? Yes? No. Again, I want to shrink it because 7 satisfies my condition, right? So 1 is excluded. It's equal to 6. Okay. So it doesn't satisfy my condition. Okay. Keep on expanding. Fine. I will expand. Okay. Now 3. So 6 plus 3 is equal to 9. Okay. 9 is greater than or equal to 7. Okay. It satisfies the condition. And what is my already value? It is 3 only, right? Okay. Fine. Now it is 9, which is greater than or equal to the target. So I will shrink it. So while shrinking it, I want to just negate this 2 or exclude this 2 from this 9. So it is equal to 7. Oh, this 7 is greater than or equal to this 7, right? And what is my window size? It is also 2. 2 is the best, right? Best than 3. So I want to add this 2 or update this 2 in my result. Okay, fine. Now I want to again I want to shrink it. So it will be what? 4 will be shrinking out. So 7 minus 4 is equal to 3. 3 is not greater than or equal to 7. Now I want to expand it. There is no more in this. So I want to stop it. What is the best answer? It is 2. Hope you understand this method. Yeah, it is more or less equal to the Cardin's algorithm. Gordon's algorithm. If you got time, you can explore this Gordon's algorithm. It is a best algorithm to find uh, which subarray sum can be equal to the target like that. But it fails at one condition. While there is a negative values in our array, this Gordon's algorithm fails. While there is a negative numbers in an array, we want to go for a subarray with prefix sum with hash map method, such that we want to take the prefix sum and put into a hash map, and we want to find whether this prefix sum minus the target is already present in that hash map. Okay, such that we can say up to that there's a subarray or subarray sum which is equal to the target or greater than the target, like that. Okay, so that's the method apart from this Gordon's algorithm. That also I told in some video, I don't know which video. If I got it, I will give in my description. Okay, now tell me, what is the time and space on t? Time on t will be over n and space on t will be over 1. That's it. Far more better than the brute force approach, right? Okay, let us see the code. So this is the code. So result is equal to float of infinity, L is equal to S is equal to 0, and I am iterating through R, and S plus is equal to nums of R. I am just taking the sum, running sum, and while S is greater or equal to target, I want to take what? Take in my result with that window size, and S minus is equal to nums of L. Now L plus is equal to 1. Okay, I am just shrinking. Now return 0 if the result is equal to float of infinity. As in question, if we cannot satisfy the condition, we want to return what? 0. That's why my initial value will be what? Infinity. That's why I'm checking whether that current value of result is infinity. If so, I want to return 0, else I want to return the result. That's it. Let me submit it. Yes, it is submitted successfully. Thank you.